Now we have a sample problem. So given are the following data for centrifugal pump. So we have the diameter of the impeller at the inlet and outlet, which is 10 centimeter and 20 centimeter. Then we have the speed, the revolution per minute, we have 1,500 RPM. Now the blade angle for the end in the entry and exit, so you have 30 degrees and 20 degrees. Now assume that the blade widths at the inlet and outlet are equal. So you have 4 centimeter. So I have here the figure ng ating centrifugal pump. Okay, so ang pinagkaiba na lang nito class is that yung B natin, so sabi niya problem B sub 1 and B sub 2 are equal. So kung anong thickness nito is the same also. If you're going to do that, you'll be projecting the line dito starting from here. So I'll be projecting a line dito. So starting here, okay, assuming that one. So when we say equal, so yung B sub 1 and B sub 2 are equal. So it will be projecting na ganyan ang magiging itsura ng impeller natin. So in-adjust ko yung blade natin dito since the given in the problem, we have the same length thickness ng ating B sub 1 and B sub 2. So you will notice here we have the same thickness na on both sides. So let's try to solve now for the radial velocity of flow. That will be your BR1. So remembering that our tangential velocity, so that will be your U sub 1. So that is equal to, or let's say the tangent, no, sorry. This is the tangent of theta. To get the tangent of theta, so we write here the tangent of theta at an angle of, we have that 30 degrees. So using that angle in the inlet, so we have your 30 degrees inlet. Then that is equal to the value of U sub 1. So dito, referring to the figure at the point 1, so we have yung angle dito which is equal to 30 degrees. Yung meron tayo dyan, we have the angle of 30 degrees. Now to get the BR1, okay, so we have the tangential velocity. So tangential velocity can be solved by means of multiplying your angular velocity times your R1 or radius 1. So tangent of 30 degrees, so that will be equal to your BR1 divided by the tangential velocity. You have your velocity fluid flow. Now to get the BR1, rewriting our equation, so we have tangential velocity times your tangent of theta, degree, angle, we have 30 degrees. Now the tangential velocity, so can be expressed natin as your angular velocity times yung radius 1 times the tangent of 30 degrees. So let's try to substitute yung values here. So we have now your velocity fluid flow at point 1. So we have, for the angular velocity, we have 2 pi. Okay, that will be multiplied by 1,500 na. That will be rev per minute, revolution per minute. Okay, so I'm gonna convert that one into seconds. So we'll have to convert it by means of 1 minute to 60 seconds. Okay. Then, multiply natin siya by your radius. Ang radius natin that will be going back to the given data. So, that will be 10 centimeter. Then, I will convert natin siya to meters. So, that will be 0.1 meter. So, that is 0.1 meter. Then, multiply by the tangent of 30 degrees. Tan of 30 degrees. Okay. So using our calculator, so we have now your velocity at the inlet. So we have the velocity of 9.1 meter per second. Now next, we'll do solving for the volume flow rate entering the impeller. Okay, so we have your equation ng volume flow rate. So that will be your Q, okay, is equal to 2 pi radius 1 and inlet. Then we have the thickness at point 1, thickness of the blade at the point 1. Then the flow velocity in the inlet, VR1. So we can directly substitute the values here. So we have your Q is equal now to your 2 pi. Then the value of radius 1, that will be 0.1 meter. Then multiply by the thickness, so that will be 0.4 meter. Then I'm gonna multiply that the velocity, the inlet, we have 9.1 meter per second. So we have now the value of your Q, or the volume flow rate, which is equal to 0.229 cubic meter per second. Next, solving for the water horsepower naman, we have your PW, which is equal to the density of the fluid times the volume flow rate. Then shall multiply by the tangential velocity at point 2, then BT T2 minus the tangential velocity at point 1 multiply by BT T1. Now, since our BTT1 for the tangential flow velocity in the inlet, so it will be assumed as 0. So we can reduce yung equation natin into density, volume flow rate. Since yung T1 will be 0 out, so we have to multiply it now by tangential velocity and fluid velocity of the tangential velocity of the impeller, then multiply it by the tangential fluid flow velocity in the outlet. So we have your BT T2. Now solving for the BT T2, the tangential fluid flow velocity at the outlet. So using the velocity triangle. So dito tayo sa outlet. So referring to that one. Okay, referring to that one, we are in the outlet point. Okay. Now, going back then, dito kanina sa triangle, velocity triangle natin. So we have BR2, which is wala tayong value. And our BTT2, tangential velocity at point at the outlet of the fluid. So wala rin tayong value. Then we have here the Then we have the tangential velocity of the impeller U2. So that is equal to the radius 2 times the angular velocity. Now we have yung angle dito of our velocity triangle, which is yung 0.2, so is equal to 20 degrees. So hanapin muna natin yung values ng BR2. So that is the fluid velocity in the outlet. So yung pa tayong value niyan. This one can be computed since this one is given, yung radius natin 2, and yung angular velocity natin is all can be computed since we have given RPM. Okay. Okay. So solving for the radial velocity of the flow at the outlet, we have the radial flow velocity, so follows the continuity equation. So yung Q1 natin, okay, is equal to Q2 or volume flow rate at the inlet, papasok doon sa impeller ng pump, and which is going out also is the same at the outlet. So we can say that our volume flow rate at point 2 is the same, is equal, but yung ano niya, usually nag-iiba yung thickness ng blade. Since equal din ang thickness ng blade, so we can rewrite now your 2 pi for the 2 pi times the radius 0.2, then multiply by the thickness at b sub 2, okay, then multiply by the flow velocity and the outlet BR2. So we can directly look for the value of VR2 since ito ay given, I already computed. So we have the values of this one. So we can compute your values for VR2 since ito yung kinakailangan natin dito to solve the velocity BTT2, okay, to get the tangential fluid, the tangential flow of the fluid velocity in the outlet. So substitute, rewriting our equations, so we have your Q2 or the volume flow rate 2. So that will be divided by 2 pi radius 2, then your thickness V sub 2. Okay. So we can substitute the volume flow rate at point 2. So since they are equal, so we have 0.229, that will be cubic meter per second, then divided by the values of your values of your 2 pi times the radius 2. So ang radius 2 natin is that will be 20 centimeter. So that will be 0.2 meter. Then multiply yung thickness because they are the same. So same din sila. Oh, sorry. This is 0.2 meter. Then multiply by thickness, we have 0.04 meter. So using your calculator, so we be able to get the value of your BR2, which is now equal to 4.56. So that will be meter per second. So we have now 4.56. I can write here 4.56, that is meter per second. So we can compute now the values of BT2. So since this is given and this is given, so we can use the tangent or TOA. So we have your tangent of the angle given, okay, which is equal to your opposite which is your opposite, is your BR2 divided by this one. So you will notice here U2, that will, ang magiging value niyan, that will be yung tangential velocity minus this one, your BTT2. So that will be tangential velocity and the tangential velocity of the fluid flow. So we have BT2. So we can rewrite or substitute yung values here. So we have now tangent ng angle, which is 20 degrees. Okay. So that will be equally BR2, fluid flow velocity at the outlet, BR2. So that will be 4.56. So the unit of meter per second. Then it is divided by U2. So that will be 0.2. So the tangential velocity, that will be 0.2 meter times 2 pi. Okay, then we have the revolution, that will be 1,500, no? So 1,500, that will be rev per minute. Then I'm gonna multiply this one to conversion of 1 minute, and then we have 60 sec. Okay, I'm gonna close parenthesis this one. Then minus your BTT2, or the tangential velocity of the fluid flow. Yes. Then finally, solving that one, so we have the values of your BTT2 using your calculator. So we have the values of 18.88, that will be meter per second. Now, let's go for solving the water horsepower. Okay. So required for the design ng pump natin. So water horsepower, so PW, so that will be your density, no? Yes. Volume flow rate, and you have your tangential velocity of fluid flow, tangential velocity of the vane, then tangential velocity of the fluid flow at the outlet. Okay. So since we're using yung nagamit natin is water, so we have your density, which is 1,000, no? That will be 1,000 kilogram cubic meter. Then we shall multiply by the volume flow rate, which is 0.229. That will be cubic meter per second. Then the tangential velocity of the impeller, yung values, that will be yung value nito, that will be 0.2 times 2 pi times 1,500 divided by 60 seconds. So that will be 31.4, no? That will be meter per second. Then we shall multiply it by the tangential velocity of the fluid flow, that will be 18.88, that will be meter per second. So finally, we have the water horsepower, which is equal to 135,902.34 watts, or let's say this is 136 kilowatt. So if we want to convert it into 1 horsepower, so we shall divide this one to 1 horsepower is equal to 0.746 kilowatt. finally, we have the values of, so we have the water horsepower of 182, 182.3 HP. Okay. Now, solving for the pump head, so we have your pump head, which is equal, your H is equal to the water horsepower, and it is divided by the density, gravity, and volume rate. So we can substitute directly since ito given na lahat. So we have 136,000. Okay. So that will be the units of Newton meter per second. Then it is divided by the density, which is 1,000 kilogram per cubic meter. Then we shall multiply this one by 9.81 meter per second squared. Then multiplying it by the volume flow rate, which is 0.229. That will be cubic meter per second. So using your calculator, we have the head, which is equal now to 60.5 meters. Okay. So let's have a quick recap ng ano natin, solutions. Okay. So let's have an overview. Okay. So starting from here, we bring down the pumps, the profile of the pump. Then we shall have solve natin ang radial velocity of the fluid flow. So nakuha natin yung tangential fluid flow at the inlet. Then we able to solve the volume flow rate in the inlet, no? So which is given naman yung radius, tapos yung thickness niya given also. Then ito nakuha na natin. Then we able to get the value of your volume flow rate at the inlet. Then for solving the water horsepower, so ito yung equation. Then since we are been assuming that our tangential velocity of fluid flow, so ina-assume that is equal to 0. So we able to reduce the equation to this equation. So then since this one given na yung density, volume to rate, tangential can be solved. What we don't have is this one, tangential velocity of the fluid flow. Now, from the velocity triangle, so from this one, your outlet, no? Okay, so mapapansin nyo dyan, we have the tangential velocity of the fluid flow. Okay, at this side, going this side, no? Okay, so by means of the velocity triangle, here we have your outlet, so which is given also yung angle of the blade, which is 20 degrees for the discharge side or at a point 2. Okay, so since ito ang wala, ang una wala ito, so we mean able to solve that by using again yung continuity equation, since ang volume flow rate entering is equal to the volume flow rate leaving the system. So but yung thickness niya in velocity are not equal. So usually nakita nyo previously, this is 1 baris, no? Nag-iiba ang thickness nito at ang thickness nun. So since the problem given is they have the same equal we call this thickness ng blade dito, so we be able to use the same also. So from there, since ito given na, this one is given, this one is given, okay, and this one is given, so we be able to solve yung tangential velocity of the fluid at the outlet fluid flow. So nakuha na natin yon, then which is 4.56 meter per second. Then substituting in on the equation ng nito. Okay? So, para makuha natin ang tangential velocity of the fluid flow at the outlet. So, from there, we be able to solve BTT2. So, we have now the value. Now, going back for the water horsepower, okay? So, we have here able to compute. So, since given ang density, volume flow rate, the tangential velocity of the vane is already been solved. Then we have the tangential velocity of the fluid flow. So finally, we able to have the value of 136 kilowatt. Now for solving for the head, so that will be H is equal to water horsepower divided by density, gravity, and volume per rate. So substituting the value, then we have the value of 60.5 meter of head in the okay, so madali lang naman siya. So it will not be complicated since everything will be solved in naman able to find in very basic computation din naman siya. So not a complicated one. Okay, so that's it.